Hi everyone, this week I want to present you another data science tips, which is the following. Negative results, they are a positive thing. So you have to internalize that negative results are good for you. So remember when I first started doing research, like most undergrad, I didn't know what I was doing. And I got pretty stressed every time my result came out negative. So my thought process was that I must have messed up something. I didn't understand some concept, or something that I didn't understand led me to have messed up the experiment. The truth was that I often did mess up stuff, but looking back to it, it absolutely didn't matter, because doing a data science project or a research project is a truly iterative process, and you're gonna mess up a lot of stuff. You remember one time there was this PhD student that was on a rotational program at the lab that I was in, and I was doing some bacterial culture in a petri dish, and I came to show him my stuff because I didn't understand what the hell was happening, and he looked at it and like, I have no idea. There's many possibilities, but it's all right. Just take some notes, try to understand on your own, because I don't know, and just try again. Truth is that's all there is. Like, the negative results that you're gonna get, there's many reasons you're gonna get them, and I'm gonna show you 3 types of negative results, but all of them are positive and are just natural thing to happen in a data science so there's really 3 types of negative result that you might get in your data science project, and like I said, all of them are kind of positive. You just need to understand in which of these bucket your negative result falls into, and then you know basically what to do. The very first one, the hypothesis or the assumption that you had was false or incorrect, and your result showed that. So this is actually very positive, right? Your analysis was correct, and it showed that whatever you thought was going to happen before you do the analysis or the experiment was actually false. That was not true. You should not feel bad about this situation. This is totally normal. This is what research is about. You don't feel on the hook to make this assumption work. The assumption are just tools in order to help you get yourself towards whatever end goals you want to get to, and you make assumption in order to make a step, right? And if that was the wrong step to take, that's totally fine. Now you have more information, and that's basically it. You just go back one step. Now you have another chance to make another assumption with more information that you had previously. So you know that this path is incorrect. You have a bunch of analyses that tell you something. You have a bunch of results. Now you can craft a better assumption. So this assumption that you're gonna make will be better than the one before, and you'll be able to go onto the right path. And that's it. There's no shame or problem with having an assumption that was proven to be false. The second type of negative result that you might get is the most common one, and the one that usually data scientists are more stressed about, is when there's a technical error. So the study design was not good, the analysis that you did was not the right one for the type of data that you had, or there's just some bugs in your code. One thing you have to understand is that that's all right too. This is perfectly normal, and actually more than this should be expected. I had this old saying when I was at my lab, that if I run analysis and it works, I'm very, very stressed. If I run analysis and it doesn't work, that's just a normal state. I'm good. I have to just check out what's up and improve it. But if I have analysis that work, I have to figure out if I didn't mess it up so bad that I cannot even see that it doesn't work. Just to tell you how much normal it is to mess up something. And if you think about it, if you're running some code or some statistical analysis using software packages or whatever it is, you should expect and you should prepare in order to catch these issues or these problems or these bugs. This is pretty standard practice in the whole software engineering field. But when it comes to data science, it's kind of not as normal or as expected to make an analysis that doesn't work. And it kind of doesn't make sense because the code that you're going to write are even more abstract and prone to errors than software engineers type of code. And I think here is just a switch in mindset and just expect that this will happen and just set up your stuff so that you can catch it, or that whenever it happens it's not as bad as if you have no harness. So software engineer, what they do automate testing, they do code review, they document their code, they do stuff like enforcing type whenever they write in order to always have like a good quality of the code base. Not all of this applies to research or data science, but I think most of it does. If you want a few tips about what you can do in order to create this kind of scaffold around your work so that it's less prone to those type of negative results, you can do stuff like working in teams with like a merge request, pull request if you're using GitHub, cadence. What I mean by this is that instead of working alone with yourself, work with other people in your lab, even if it's not the same project that they're working on. And every time you want to push into your own code base and repository, you make a merge request instead of directly pushing into the stuff. If you're not familiar with Git and whatever and all of this, might sound a bit weird, but basically instead of like always building upon your work, keep the main code of your thing that was there before clean, and then whenever you want to make an additional you add analysis or you improve something, make a merge request and ask for a bunch of people in your lab to review it. It may look like a big time sink, but actually really help promote the knowledge around the lab, ensure that all the analyses are good and that some pieces can be reused. And then what will happen is that a bunch of other programmer will look at your stuff, will comment if they don't understand something, and then you will go into round of improvement for your analysis. And then when they say, yeah, it's good, you can just merge it and move on. But this also implies that yourself, you'll be reviewing other people's code in your lab, or your team if you're working in a data science shop. I think the merge request kind of cadence, in the long run, it's much more productive than not having it. Another tips is just like isolate your code and just test it for correctness. Data scientists usually don't do that, but I've done it before and it's actually very useful. If you don't know what test to write, just kind of isolate your code into like bucket and try to do like the minimal type of check you will want to have for this type of analysis. And then if you think about something else while you're coding along, just add this in your automated test. Another tip, just document your code as you're writing it, making sure that it's always in a state that is easy to understand. If you're doing the merge request cadence with the rest of the team, this will happen naturally, because if the people will read your code and there's no comment, there's no documentation, they will tell you, and it will be hard for them to understand. But when there is, it's easier for them to go through the flow, so naturally your code will be of higher quality. Last thing, tips that I can give you, I've tried it for last few papers I wrote before I dropped out of my PhD, is to do a report-driven development kind of methodology. So what does it mean is that you kind of write the report as you code. So I always try to, like, you're always working toward a project, a research objective or something. So I try to write the report as if it was a paper. And as I'm doing analysis, I'm just adding information to that thing. It actually helped me a lot because, well, first I have kind of a simile paper to show for at the end, but they help me always go back to the study design, the higher level aspect. It's not really the code that I'm trying to check for correctness here, but more about like my logic going, what I'm trying to do with the code in order to get to the end result. And at some point, if I write my report and whatever I'm doing is not making any sense, I can catch this pretty easily. It's normal to have bugs, it's normal to have errors in your code. Just make sure that you have a scaffold to catch them and that you minimize as much as possible these type of error. So the final kind of negative result that can happen is actually the most exciting one, is when your actual results contradict another result from another group, so another team, another lab or something. This is very positive because well, first you found something that we thought was real, that was actually not real, or that was wrong or something like that. So this is an immense opportunity for you as a data scientist, as a researcher, because then you get to kind of get a free pass to network with another group, because like you have something that that they messed up or that they didn't think about. So this is the perfect opportunity to go there, talk to this other group or this other team and show them whatever you found, and work together with them in order to correct it, improve it, and just figure a way to kind of make it work. This is very cool because usually when there's a lot of incentive to make a project move forward, it will move forward really fast. And if it's something as critical as another lab or another team member, another team having error into their analysis that they publish and that they shout out to the world, usually the incentive is pretty high to make the thing move forward. So to conclude, whatever type of negative result you get, take a deep breath and say, great, it's normal. This is just part of the thing. There's just going to be failure upon failure upon failure until you hit your whatever positive result that you were trying to get. It's not up to you to decide if you're getting a negative result or not. Of course, if your code is wrong, that happened, but this is expected. So you just need to make sure that whatever environment you create around yourself allow for this positive result to emerge. So an assumption is wrong, fine, let's refine it. My code is not that good, perfect. Let's create some sort of harness around me, around whatever I'm working with, so that I can always create a code of higher quality. I found errors into the work that I'm basing myself upon. Perfect, this is good. Let's try to figure it out and understand this so that we can move on and create something even better. All of these are positive things, and you just have to switch your thinking toward this, and that will automatically make you a much better data scientist or researcher in the long run. So that's it. If you have comments about this or your experience, don't hesitate to comment them in the comment section, and I wish you all a fantastic week.